Hello everyone, this is Algebra 2 1.6, and need to work with you guys starting with inequalities. You guys should remember that there are open and closed symbols. Open symbols would be greater than or less than. Closed symbols would have the equal sign with it. So when you're graphing it, you have a choice of whether the symbol is open or the symbol is closed, depending on what it's telling you. So again, closed is greater than or less than, or equal to, sorry, greater than or equal to, less than or equal to. Open is strictly greater than or less than. These two are actually exactly the same thing. When you read from the variable, you have x is greater than 5. Don't read it from left to right. Read it as if you're reading a manga, that you can read it from the, in this case, right to left. So x is greater than 5. X is greater than 5. They say the same thing. That's one of the things you guys will need to get used to this year, is that you're going to read from the variable rather than always reading from the left side of the page to the right side of the page. So read from the variable. I will take either one, but I want you to understand that it doesn't necessarily mean which direction the arrow is pointing. You guys are used to, say you have 5, open circle, because neither of these have the equal sign, that this is less than. This is greater than, which is correct. For some reason I feel I spelled that wrong. Okay, I'm not trying to fixate on my spelling here. What you need to realize is that I understand that this symbol is pointing to the right. Yep, it means greater than. But don't rely on which direction it's pointing to tell you which way to graph. Yeah, it's pointing left, but you don't graph to the left because you read from the letter. X is greater than 5. Maybe you never made that connection to which way they're pointing. Some kids do. Some kids rely on which way it's pointing on which way to graph. But read from the letter. X is greater than. Okay. Right now this says x is less than or equal to -4. So at -4, 4 not 9. I don't know why sometimes it closes. It's a little frustrating for me on why the software sometimes does that. It's equal to, because it has an equal sign, x is less than, so I shade left. All right, that would be the answer for this one. Whereas this one would be -8, closed circle, again because it has the equal sign, x is greater than, so then you shade to the right. Okay, so there you go. Next page. This says, so let's put the two numbers on there, -3 and 4. This has an open circle. This one has a closed. X is between those two, so you shade between them. Another way to see it, read from the letter. X is greater than -3, so you're shading to the right. X is less than or equal to -4, so you're shading to the left. They're shading at each other, so you shade between them. All right? That says the same thing as this. For example, how about 2? 2 is a solution to this because it's between them. It's saying 2 is greater than -3 and it's less than or equal to 4. It's both things. It has a foot in both camps. It's not only greater than -3, but it's also at the same time less than or equal to 4. So the word that you're focusing on there is the word and. It's doing both. All right, looking at this one, same two numbers. Open circle on 4 this time, shaded to the right because it says greater than. X is greater than 4. This one has a closed circle at -3. X is less than or equal to -3, so you're shaded left. So let's pick a number that's a solution. How about 7? 7 is a solution to this piece. It's a solution to this whole thing because 7 is greater than 4 or it's less than or equal to -3. It's one or the other. It's satisfying this one or it's satisfying that one. It turns out it's satisfying this one. So the word that I'm focusing on is or. When your graphs are shaded away from each other, this one's shaded that way, this one's shaded this way, it means or. Right? When they're shaded at each other, it means and. Okay? I bring this up because when they're written as it's called a compound inequality. It means and. But yet, when you look at these, -3, open circle, x is greater than, I'm shading this way, x is, so 4, closed circle, I'm shading that way. It doesn't make sense. How could you be greater than -3 and greater than or equal to 4 at the same time? You can't. That doesn't make sense. It's not sensical. Okay? So be careful writing compound inequalities. All right, jumping over. When you're solving stuff with inequalities, you're still following PEMDAS. You're still solving, so you're going to go up PEMDAS. Start by undoing the adding and subtracting. -3 minus 3, x less than -2. Life is good. Add 5, add 5. X greater than or equal to 7. No problems. Subtract the 7, subtract the 7. -3 less than or equal to x. All right. Now, just for the sake of argument, I'm going to graph this thing. And there's 7. Closed circle, because it has an equal sign, shaded right. I'm going to pick a number that's in the shaded area. How about 10? It looks like 10 is a solution to this. I'm going to go back to this one and fill 10 in for x. So that would be 10 minus 5, and you're asking, is that greater than or equal to 2? 10 minus 5 is 5. 5 greater than or equal to 2. Yes, it is a solution. Now, why I did that is just, I'm going to reference this idea in just a second. Okay? So here, divide by 2, x greater than 3. You're multiplying by a fraction, so to get rid of it, multiply by the reciprocal. X less than or equal to 10. It's a 10. You're multiplying by 3, so divide by 3. X greater than -3. Again, I'm going to try graphing it and show you something. -3. Open circle, shaded right. I'm going to pick a number. How about 0? 0 should be in the solution. I'm going to take 0 and fill it back in the beginning. 3 times 0 greater than -9. 0 is greater than -9. Okay, strictly greater than. So again, yes, it worked. So our solution is good. Why I'm doing this will become apparent on this next screen. Okay. You're still using PEMDAS. You're still going to undo stuff in order that you're going up this. All right. You're multiplying by -3, so I'm going to divide by -3. So you have x less than 4. Now, if I'm going to graph this and show you something. Open circle, x is less than, shaded this way. How about 2? 2 is a solution to this thing. So let's try 2. Fill it back in. -3 times 2 less than -12. Is -6 less than -12? No, it didn't work. There's a fix you have to do. There's a correction. Whenever you multiply or divide, when you have an inequality, there's a fix that has to happen. Otherwise, it doesn't work. I just showed you. It doesn't work. So how do you fix it? Whenever you multiply or divide across an inequality with a negative number, you have to flip the inequality. And the fancy way of saying flip the inequality is you change the sense of it. You change the sense of the inequality. So when you divide by the -3, this still becomes x, this still becomes 4, but you have to turn the inequality around. Now let's try it. It's supposed to be shaded right. How about 6? 6 looks like a solution. Stick 6 in. -3 times 6. Is that less than -12? Is -18 less than -12? Yeah, it is. It works. So the fix, the correction, whenever you multiply or divide, by a negative number when you have an inequality is you have to turn the inequality around. Oops, I don't know why I wrote 6. Obviously not doing the arithmetic. Negative 9. Okay? Here you're multiplying by a fraction, so multiply by its reciprocal. X is greater than or equal to 21. All right? So subtract the 3, subtract the 3. We're still using PEMDAS. 2x greater than, so what would that be? 8. Divide by 2, divide by 2. X greater than 4. Again, about showing your work. This is what I'm looking to see. Show me your work. All right. Subtract the 3, subtract the 3. Negative 2x, that sign stays with it. Right? That's a positive 3. I got rid of it by subtracting it across. This symbol stays with it. Less than or equal to 2. Now when you divide by the negative 2, you got to change the sense of the inequality. There you go. Subtract the 3, subtract the 3. This symbol stays with the x. That's a negative 1, so when you divide out the negative 1, x, turn the inequality around, 6. When you have more than one variable, I'm going to start by adding the 2x over. It's just a preference. I like to start with the variables. 1 greater than 3x plus 10. Subtract the 10. So then you have negative 9 is greater than 3x. Divide by 3. So you have negative 3 greater than x. Now, what I'd like to do is encourage you guys to read from the letter. X is less than negative 3. X is less than, rather than reading negative 3 is greater than x. I don't know what that means, but if you read from the variable, x is less than negative 3, it makes more sense. Okay? I think that's all of them on this page. When you have, it's called a compound inequality, it doesn't, if you guys only had this much, what would you do? You'd start by subtracting the 5. Okay, well, what if you only had this much? You'd start by subtracting the 5. Okay, well, start by subtracting the 5. Negative 3 minus 5 is negative 8. The x is there, less than negative 3. You're done. Start by adding the 4 out of there. So 4 less than or equal to x, less than or equal to 11. No big deal. There you are. When you have two separate ones separated by or, remember these are and because it's between them, x is greater than or equal to 4 and less than or equal to 11. This is or. It's two separate ones. Just do them separate as if it's two separate questions. Now do this one. And the word or is still between them. X is less than negative 6 or it's greater than 4. Just two separate equations. And that looks like it. Thanks for your time.